Well, good afternoon. Welcome back from lunch. I hope you all, got some nice warm carbs in you to counterbalance the very frigid temps this morning. So we're here now for a presentation from Intuitive here in town. This is Vision to Value, a layered approach to AI in defense and aerospace. That's a topic that probably resonates pretty well with this audience. I'd like to introduce our three panelists for the afternoon. We have Dr. William Marx, who is the Senior Vice President and Chief Technical Officer at Intuitive. And as in that role at Intuitive, Dr. Marx oversees the development of strategies, businesses, and operations planning for technology and systems required to maintain a competitive edge within Intuitive's marketplace. He is responsible for developing the technical vision of the company, aligned with the company's technology needs, business objectives, and customer missions. He joined Intuitive in 2013, and prior to coming to Intuitive, he held various technical positions with Rockwell, the Boeing Company, and Schaefer Corporation. In these capacities, he worked with the U.S. Army, Air Force, Navy, MDA, NASA Marshall Space Flight Center, NASA HQ, and DARPA. He was also an adjunct associate professor at University of Alabama, Huntsville, where he taught engineering economics. Also, with our group today, we have Daron. Daron is a division manager at Intuitive and leads the company's support of the Army's portfolio acquisitions executive fires. In this capacity, he leads support to Army weapons system project offices for offensive, defensive, and integrated fires systems. He is also a subject matter expert on DARPA's Air Combat Evolution Program for the development of artificially intelligent battle management agents. Prior to his current role, he served as the Director of Test Planning and Design at MDA, leading the strategic planning for MDA's $1 billion year test program, spanning the U.S. Army, Navy, and Air Force missile, sensor, and command and control systems. In this capacity, he resolved budget planning shortfalls with U.S. Congress visibility, and led test design and range safety planning for complex missile defense flight and ground tests required worldwide. Also on our panel, we have Madison Travis, who is a digital communications specialist. As a digital communications specialist at Intuitive, she is responsible for developing an effective marketing strategy, curating digital content, and managing digital platforms for Intuitive, transforming technical capabilities into an impactful message. Additionally, Madison plays a key role in educating employees about technical priorities and emerging technologies, while also overseeing external communications across the company's website and social media platforms, in partnership with a team of graphic designers and content personnel. Give a warm round of applause to our panelists, starting with Dr. Marx.
Thank you. Good afternoon. All right, thank you. Good afternoon, we'll go with that. Thanks for attending our session. We appreciate it. We're going to be discussing how to transition AI from vision to value. We've assembled our thoughts on how we're approaching AI with a layered strategy, both for ourselves and our customers. We're not just saying, hurry up everyone, start using LLMs and agents and everything gets, magically better and faster. That's not how it works. Our presentation is meant to be practical and actionable for everyone in the audience. We're going to include a practical framework and an actionable assessment tool that you can use to introduce AI to your company or your team, or to take your existing AI to the next level. I'm going to start with a question. Is AI a mission capability in your organization? I'll ask it again. Is AI a mission capability in your organization? Are you using it, or are you just talking about it? Are you advocating it to your staff or your colleagues? Are you actually improving anything? Or are you stuck in that AI paradox? How many of you are here at this symposium for the first time? I'm curious. A bunch, okay? Down. How many second time? A few? Third time? All right, very good. I've been here 3. I work at a defense contractor, and this is indeed the question we're asking ourselves, and it's the same question that we're helping our customers ask themselves. So what's the answer? Well, hopefully it's not a science project, but what is your answer, and how far are you into your AI implementation? Maybe you've only got subgroups of employees starting to use LLMs, and you don't have any results yet. Or maybe you've developed a few agents, but they haven't changed any department behaviors yet. Those aren't real good answers to my question. But I think a lot of people find themselves here without a good way to assess where they are and where they're going. Our talk today should give you some ideas for determining where you are and where to go next so that you can derive value from your AI vision. All right. Now let me say a few words about each one of us before I get into the content. So I'm the Chief Technology Officer at Intuitive Research and Technology. We're a Huntsville-based defense contractor. We've got more than 600 employees around the United States. Do a lot of work for the Army, Air Force, and several other federal clients. I've been around AI myself for about 30 years, starting with expert systems and knowledge-based systems all the way back in the early 90s when I was in grad school. Daron is over here. Daron is speaking after me. He's going to get deeper into the layered approach, which is rooted in systems engineering. Daron is not only a systems engineer himself, but he's one of the most systematic engineers that I know. His way of thinking is the basis for our talk today. Cool fact about Daron, he's also a retired pilot. Now there's a lot of retired pilots around Huntsville. Most are Army helicopter pilots. Daron, however, was an F-22 Raptor pilot in the Air Force. He also flew the F-117 Nighthawk for a couple of years. If you like that kind of stuff, catch him after our presentation. He really loves to talk to people. And third, Madison Travis, like me, is not a fighter pilot or former military. However, she did just recently complete her executive MBA at UT Knoxville, and her area of research was implementation of AI within the aerospace and defense domain. So she's going to be talking about a readiness framework and a make versus buy approach for AI that fits nicely into our layered approach. All right, these are the topics from our abstract. I included many current AI and large language model buzzwords. I've also added several others. I've got human in the loop, man in the loop, and systems engineering. All of these ideas factor into how we think about employing AI, whether agentic or something else. I'm not sure if the control room can hear me. Oh, there we go. Thank you. We're back on. All right, all of these ideas factor into how we think about AI, whether it's agentic or something else. Systems engineering down there in the lower right is a key part of our approach. Systems engineering is a very important discipline within the aerospace domain. Systems engineering applies a systematic approach to the integration of other disciplines with special emphasis on interfaces and boundaries. The systems engineering methodology applied to something complicated, like missile defense, leads you to a layered approach to maximize system effectiveness. That layered approach is central to our talk today. So let's take a look at the agenda. We have 6 major topics that we're going to cover. First, I'm going to talk about some overarching types of AI, some approaches and terms, and then next, I'm going to talk about how we're taking some AI tools and practices from other industries and using them in aerospace. And then I'm going to introduce some examples of layers. Now, we all know what the word layer means, but I'm going to set things up for Daron. And then Daron's going to talk about our layered approach, specifically tailored to AI. Madison will cover that objective framework for AI readiness and implementation. And then she'll discuss the next steps for you based on our layered approach to help translate your vision into value. And finally, I'll wrap it up with a few key takeaways. All right, what is AI? After we finished this chart and we sent it in to meet the deadline, I decided a better title for this chart really isn't what is AI, but it should be what AI isn't. The left half of my chart is a terrible Venn diagram. I made this terrible Venn diagram on purpose. AI as a concept was introduced in 1956. It was largely theoretical at the time. We didn't have the computers and processing power to make it anything but theoretical, but it's evolved over decades into what it is now. And now if you look at that Venn diagram on the left, a lot of the public uses ChatGPT and they think, oh, I got this stuff. I pretty much know AI because I know ChatGPT. So I put a big red X by that side. Yes, ChatGPT uses AI, but there's so much more to AI than ChatGPT. I could have made the diagram on the right in many different ways, but I chose this one. Within that AI circle, there's a lot of sub-disciplines, of which the most visible one, perhaps to the public, is large language models, the LLMs. So I gave that its own circle. If you're using ChatGPT or Claude or Gemini, yes, of course, you're using AI. If you shop with Amazon, or if you get a movie from Netflix, or check your feeds on Facebook, you're also using AI. Or more accurately, you're a consumer of AI, or actually a trainer, because you're providing training inputs to their machine learning whenever you like or click or buy something. Your camera on your phone has computer vision. If you have a drone, it uses robotics, aerial robotics, and autonomy. And the focus of this symposium is agents. So you can create an LLM-based agent to answer your email or answer your phone calls, that's fine. But you can also create agents that work across anything in that AI circle, anything on the right, across any of those sub-disciplines. So let me give some specific AI and agentic examples from the aerospace community. The aerospace industry moves slow, but we watch commercial companies and we can take advantage of best practices to help ourselves. For LLM applications, there's several things that we want to adopt and things that we don't. So on the left side, I say we could use LLMs to generate more stuff that people don't want to read. I don't need that, red X. On the right, we do use evaluative AI, that's my own term, not just generative AI, but we use evaluative AI to objectively compare and score documents. I can use large language models to quickly assess compliance of large documents or families of documents. I can take a quality standard like AS9100 and I can compare an entire quality management system library to it. I can very quickly determine gaps and traceability and semantic relevance. LLMs make that easy. Daron's going to get deeper into this, but for areas that have a lot of written content, written in some type of language or even computer code, LLMs make outstanding agents. Now, agents, left half. In my business, I don't need a chatbot with a nice accent or perfect grammar to answer my phone calls or my emails. Personally, I don't like speaking to bots when I call my health insurance provider when I want some help. I can wait to talk to a person, or I can wait for someone to answer my email. I don't like those bots. So red X. Right half. I am, however, interested in using agentic AI to replace workflow steps that are repetitive. Things in our purchasing department, could be accounts payable. There's a lot of applications for agentic AI in aerospace. The text on the right side mentions process automation. I've got that in bold, process automation. This is true, but what we're really aiming for is decision acceleration and decision automation using agents. Third one, computer vision. I didn't make a left half for this chart. I only made my good example. But if I hold my phone up and I use my camera app and I hold it and I take a look at Daron and Madison, I'm going to quickly see that yellow box around their face. Voila, that's computer vision. Computer vision has identified them for me as if I couldn't see them. But I could focus on them, or I can use portrait mode or whatever I want because the computer vision found them for me. Now, agentic computer vision models are very powerful. You can use those to automatically find tartar buildup in your dental x-rays or triage CT and MRI scans in the emergency room, putting the most critical patients at the top of the list for treatment. They can also be used for automatic target recognition, for delivery drones and military drones. So all three of my examples on these charts, the last three charts, are specific applications that could be used within the aerospace community. They could be considered core applications in aerospace because they have very focused purposes. There's also reasons to implement AI at the surface layer of aerospace, I'm going to talk about that now. So in aerospace and defense, things are changing, and they're changing fast. Watch the news. What are other countries doing? What are we doing? Everything from how our businesses operate to how we design and test systems to how we use those systems in the field, AI can help us in all of those areas. AI can help with resilience by providing robust testing using digital twins. AI can help with autonomy for aircraft, drones, and missiles. And AI is needed to provide superiority over the AI systems of our adversaries. And for charts. We counter AI with better AI. So let me cover one last topic, that's autonomy, before I get to the layers. All right. There's a lot of concerns about autonomous systems. They could be autonomous delivery drones or a simple agent that answers your email. Some are more critical than others. Our symposium theme is agentic AI. I've got 5 kinds of AI agents listed in that lower left block. All could be autonomous. All have critical impacts depending upon their application. In my word diagram a few charts ago, I introduced the acronym MITL, stands for Man in the Loop. It's borrowed from the military. Basically, it means that we keep a human in the decision loop to prevent an unwanted outcome. That's that middle block. That middle block is key, especially for autonomous agents that take action or make decisions that are critical. Autonomous agents could be very critical. Say we have an agent that diagnoses scans in the emergency room radiology center. That's great, it's fast, probably better than humans. But we're going to want that radiologist double checking the results of the agent-based diagnosis and the recommended treatment. And for decisions related to national defense, security, I want the human operator or the military officer validating the fire control solutions from the computer vision and planning algorithms. I want to maintain the human in the loop for mission critical systems. And in the third block on the right, we do use AI to accelerate and focus, but we need to keep the human in the loop for critical missions and critical outcomes. In a few years, things are going to change. They're already changing. Many AI agents will continue to be more capable and more trusted, and some may not. Either way, we're headed forward, and that's my lead into the layers and why we need them for AI. All right, so I'm finally here to the layers. Our layered approach, I'm going to cue this up for Daron. I'm going to give 3 examples. I'm going to talk about cybersecurity, football, and missile defense. On the surface, these topics may not seem related, but from a certain point of view, they are, and hopefully a good vector into layered AI. First is my cybersecurity example. This one should be obvious. When it comes to protecting your critical assets, you construct your cyber defense in layers. This approach is called depth in defense. If one layer fails, other layers will protect the asset. It's pretty simple. The most critical items, perhaps your payroll, inventory, supply chain, trade secrets, proprietary information, those go in the innermost layer with the most protections. The outer layer is the one that faces humans. If there's a breach there, it can only go so far. So that one's easy. The next one is football. Now, if I look around the room, I see 217 of us. And so there's maybe 216 of you saying, all right, football, what have you got? And there's one of you saying, you're kidding. You're going to talk about football. That one of you would be my wife. I won't point her out, but she's in here. After 30 years together she knows I'm not a football fan. Both of our son and daughter are down in Tuscaloosa. They're not football fans either. But this is the second time in 30 years that she's heard me talk at a professional conference. And she's probably wondering, where is he going with this? How is he connecting football to artificial intelligence? So we'll give it a shot. So in football, if you look at my diagram, if a defensive formation always looked like this, what I've labeled layer one, not really a good idea. If the offense breaks through this single layer of defense, nothing stops them from reaching their objective except maybe a very fast defensive player. But that's mitigation after the layer has been breached. We don't want that. So instead, we use multiple layers. In this case, multiple layers of defenders. I've labeled very cleverly layer one, layer two, and layer three. Again, this is that defense in depth strategy I mentioned for cybersecurity. If the offense makes it through the first layer, there's more layers to stop the bad outcome. I know you can throw a pass over the layers or kick a field goal to bypass the layers, but you get my sports analogy about layers. Third example is missile defense. Missile defense can be really complicated. Fundamentally, it's really simple. The diagram on the right is similar to my cyber example. You put the asset that you're defending in the innermost layer. If the bad actors try to prosecute our asset, they'll have to get through multiple layers of defensive systems. It's that defense and depth strategy again. Someone's prosecuting my layer 5 consistently. Our layered approach for AI isn't necessarily about defense or offense. Instead, for AI, it's about function, utility, security, autonomy, governance, and risk. And all those functions are addressed with our layered approach. With that, Daron, you're up. Yep. Top one advances.
Well, good afternoon. It's good to be with you all today. I'm Daron, and I'd like to start with a short story. So 20 years ago, I was standing in my backyard at Edwards Air Force Base, having just arrived for my next Air Force assignment. And we were moving into our house, my wife and our 3 daughters at the time, a house that, interestingly, had been standing in the same spot since the first sonic boom shook that desert. It's an old house. It's good enough for Chuck Yeager, I guess good enough for us. And I leaned over the fence, it was actually a cinder block wall in the backyard, and engaged my neighbor, who I had not yet met. And I said, he was grilling. I said, what are you cooking? And he said, onions. And I replied, no, I mean, like, what meat are you cooking? And he replied, I'm grilling a big slab of onion. That's the main dish. I had never fathomed that, nor have I tried it to this day. But fast forward 20 years, and the meat of my presentation today is an onion. Onions have layers, as Dr. Marx explained. This talk is about a layered approach to AI. Most people tear up when they peel into an onion, but my hope is as we slice this onion together today, you won't cry, but instead you'll walk away with a very practical and intuitive framework for how to approach AI in your company and with your customers, no matter what industry you're in. I should warn you that this blue onion, besides being blue, has a couple unique characteristics, which will become evident in a minute. First of all, the center has multiple cores, so there are multiple centers. And second, I've numbered the layers in a way that you might not expect. All right, so let's jump into the outermost layer of the onion. AI implementation layer 1 is individual productivity and literacy. And this is the ground floor of AI on any team. And you may be thinking, well, this is pretty simple, and it is, but again, we want this to be very practical so that this can be applied as you implement AI in your company or for your customers who may not have any AI at all. I'm going to contrast the 3 layers of this onion using 4 factors that you see there. How broadly the AI is used, the cost of the AI, the customization, and the degree of training required. We can summarize layer 1 depicted here as AI for everyone. Broad use of inexpensive AI tools, such as large language models, which I'll call LLMs, as Bill did, Often in layer 1, you don't have to buy it, make it, or customize the AI. You provide easy access to LLMs and encourage everyone to explore and learn with little or no training. Remember, the goal in this layer is to grow general AI literacy and increase trust in basic AI tools. So question for you, practical question. Does layer 1 describe your company in terms of AI implementation? Or is this something to which you aspire? Be honest. Your company, your team, your division, and your government organization. Or perhaps you're well beyond this level. For AI implementation layer 2, we go all the way to the center of the onion. And as I said, there are multiple centers. In layer 2, you implement standalone agentic AI tools. That is AI that can act autonomously on specific tasks or decision sets. Now, not everyone in the company obviously is going to use these layer 2 tools. Only those people responsible for the targeted business scope or decision areas selected for layer 2. How much does this cost? Layer 2 costs vary widely. Custom tools require financial investment but can yield significant savings over time through process automation or rich decision support. And as you'd expect, specific training is required for those that are going to use these customized layer 2 agents. Notice that in layer 2, the agentic AI tools are standalone. So we've got multiple cores of the onion, but they're all operating relatively independently, each one addressing a specific need. They are not integrated. They do not talk directly to each other. They each serve a specific purpose, and they do it well. If your company has already implemented custom AI tools like this, great, you're ahead of most. If you haven't, and you're still intrigued by layer 1, paying attention to the characteristics of layer 2 and 3 that I'm going to present will still help you. Because no matter which layer you're currently in on your team or with your company or with the customer, you need to think about the implications for the later layers because they are related. And this brings us to layer 3, integrated agentic AI. Graphically, and this is where the layers in the onion are a little bit counterintuitive. We're basically going back out to get to layer 3. Graphically, this layer, layer 3, envelops layer 2, the multiple cores. Because in layer 3 integrates the individual agentic tools from layer 2 for cross-enterprise benefit. Layer 3, therefore, is actually one step back out from the center, as I said. In layer 3, interfaces between each custom tool are identified, and the AI tools in layer 3 will share information for maximum synergy. The AI tools are cooperating with one another and doing so in ways and at speeds that exceed human capability and capacity. This often is the most potent layer of AI implementation and understandably is often the highest cost. But once again, the financial investment is recouped over time as significant processes are automated and made more potent. And by this, I mean faster, better decisions or faster, better information output. It's important to note that in the ideal case, your implementation of layer 2 agents should be informed by your downstream intent for layer 3. In layer 2 planning, so when you're in layer 2, decompose your organization's functions, mapping the flow of information or decisions through your organization. And then identify those decisions or sets of decisions that are frequent, complex, or time-consuming. Next, select several of these functions that are adjacent to each other in your workflow or process flow and convert them from human agents to computer agents, to AI agents. And the reason you want to select adjacent functions for layer 2 is so that in layer 3, you can integrate these adjacent agents and remove the human interface between them. So to recap, layer 1 is AI for everyone. Layer 2 is custom AI agents for specific tasks. And layer 3 integrates those agents enterprise-wide. So let's see this in action with an example. We're going to march through the layers again. Let's say you work in the healthcare industry at a large medical clinic, for example. The clinic initially where you work, is not using AI at all, and therefore begins at layer 1. The clinic wants as many employees as possible to become familiar with LLMs and be more productive with them. But we have a challenge in the healthcare industry. Due to HIPAA requirements and other laws intended to safeguard or designed to safeguard patient data, the clinic must implement an internal large language model that has access to all patient records. The medical providers individually, each person, uses this LLM to search patient records for data and trends. And they can do so more quickly and more richly than before because the LLM can extrapolate user intent from the specific user prompts, as many of you have experienced. So what happens? Word of mouth among the clinic employees spreads increasingly better techniques for prompting the LLM as employees move from, well, that's interesting, to, wow, this is really powerful, just saved me many hours of work, as they share their experiences with each other. So layer 1. During this period of LLM experimentation and use, a small team meets regularly to identify key functions in the clinic's operation that could benefit from deeper customization, more deeply customized AI, and that is layer 2. So after brainstorming, they down select 2 functions in the medical clinic: diagnosis and treatment. The clinic hires an external firm to develop a custom agent to read radiological imagery and then diagnose and recommend a treatment. Then separately, the clinic develops a second agent, a second core of the onion, that scans blood work, lab results, and other data in a patient's record and recommends a diagnosis. While the radiology agent and the blood work agents operate independently, each significantly improves the speed and accuracy of diagnosis and treatment in their respective domains for patient benefit. Now, after working on these 2 layers for about 6 months, let's say, tweaking them and building trust in them, the clinic decides to move to layer 3. First, the domain-specific agents from layer 2 are replicated and extended across all medical disciplines at the clinic, including all laboratory services, radiology, ultrasound, cardiopulmonary diagnostics, immunizations, and preventive screening. Then these agents are connected into an integrated whole with complete sharing of data and diagnosis and treatment recommendations by each agent. And all of this is fused into a single diagnosis report and treatment recommendation that considers, amazingly, but we're getting there, right, the patient's complete history and considers best available research on drug interactions and treatment interdependencies. The human medical team then reviews these AI-generated reports and recommendation and makes the final decision on treatment. Now, this healthcare example shows how one organization might progress through the layers of this AI implementation model. But implementation varies across industries. I imagine many of you are not in the healthcare industry. So we have a framework to help you understand 3 key factors for AI implementation in different types of companies. Before I show this framework, I want to foot stomp something. It's likely that the content that we are presenting today merits further digestion after the conference. So we hope you'll take with you these frameworks that I'm presenting and the assessment tool that Madison will soon present, and consider applying them in your company or on your teams. And use them to analyze your customers and make thoughtful recommendations to them for AI implementation. All right, this framework. This framework compares 3 types of companies in the blue columns and 3 AI implementation factors in the rows. And the overarching question is this: how does implementing AI in the 3 onion layers that I presented look different in different companies? And I'm going to compare using 3 key implementation factors. So let's start at the top right with the double-sided arrow representing a spectrum of companies. On the left extreme, we have companies or teams that primarily rely on natural language. Natural language is simply human language, such as English. On the other extreme, at far right, we have companies that are highly number dependent, such as the engineering or financial firm that I have listed there as the example. And in the middle are the tweeners, teams that significantly rely on both natural language and numerical data. In the blue columns, the light blue column headings there, below the arrow, I provided 3 example companies. First is a small marketing firm, highly language dependent on its content creation activities. At the other extreme is an engineering firm, which deals heavily in numbers and geometry, and less, obviously, in English sentences and paragraphs. And in the middle, we have, again, the healthcare organization or healthcare firm. To compare how these companies may need to apply AI differently, let's start with the top row. Implementation factor 1 is adoption. This factor asks this question. Here's the consideration. How useful do employees perceive AI to be? Do they trust it? And how does this factor affect each layer of the onion that I previously explained? So for the marketing firm, layer 1 LLMs, as you might imagine, are very useful in increasing AI literacy and trust. Content creators at this marketing firm first use and then eventually firmly rely on AI to improve their marketing content, including words, slogans, and graphics. Some of you are likely doing this today. For this type of company, layer 1 is very valuable in enabling and preparing for layers 2 and 3 by, like I said, building AI literacy and trust before more expensive tools are introduced. Moving to the engineering firm on row 1 at far right, layer 1 large language models are less fruitful because engineering firms rely less on natural language and more on math and geometry. Therefore, an engineering firm may need to use layer 2 to really build and spread trust in AI within the firm. All right, let's look at factor 2. Factor 2, the second row, is risk and compliance. The associated consideration here is that risk and compliance burden vary by layer and by situation. In a small marketing firm, the content generation team has essentially no safety risk, for example. They do have some risk of losing proprietary information, but it is not as high a risk as in the other company types. Likewise, there are few regulations in this space, and compliance burden is therefore low. Now, if we go to far right, for factor 2, we have the engineering firm. Not only must proprietary design data be secured, but there also exists safety risk or design performance risk. For example, an engineering firm might use a custom AI tool to perform automated parametric analysis or sensitivity analysis, or to explore the design trade space iteratively and quickly to produce a novel design solution that humans would not intuitively consider. Is this AI-generated design safe, or will it perform well? This risk must be considered and mitigated when AI is implemented in companies at this end of the spectrum. Finally, the bottom row in this table highlights the third key factor for AI implementation in all 3 of the onion layers, and that is governance. And the key question here, the key consideration is, who owns the truth? Throughout history, we have rightly established authority structures on human teams, and we must do likewise on teams of AI agents and on hybrid teams where computer agents and human agents work together. So let's consider factor 3, governance, across our spectrum of companies. The marketing firm obviously operates in creative domains, or a creative domain, where there's no really single right answer. But in healthcare, authority structures are very important. In layers 2 and 3, where agents are diagnosing patient conditions and recommending treatment, lives are literally at stake. What I would call a truth hierarchy must be established to govern which agents, whether human or machine, have final say over a scope of decisions. For example, you may trust AI to meter the flow rate of the saline drip in a loved one at the hospital. Would you trust AI for that? I'm curious, how many would today? Do you actually know if that's happening in the hospital? Saline, not huge risk. But in contrast, we would likely not let AI have the final say on chemotherapy selection or dosage, right? So the basic challenge of governance is the same as it was before the computer age, before the AI age. Who has authority where? The new thing today is that some of the deciders or agents are computers that can make decisions better in some cases, and in many cases faster than a human can. Now consider the engineering firm. We're in the extreme bottom right cell on the table. Here, the key governance task is to establish which engineering database or design baseline is the authoritative truth source from which all other agents draw their design information. In many ways, this is similar to the healthcare example. In both healthcare and engineering, lives are obviously at stake, which means the stakes are high, and therefore we must carefully plan authority structures or governance when implementing AI in any company, especially in layers 2 and 3. All right, in summary, I presented a pretty basic 3-layer model for progressive AI implementation using the onion metaphor. I then described 3 key factors for consideration in applying each layer in various types of organizations, depicted up there now. We encourage you to take the onion model, take the blue onion home, and the framework of these 3 key implementation factors and consider applying them in your company or on your team or with your customers. But we have more practical advice for acquiring the right AI from the right source for your team. And for that, I welcome my colleague, Madison.
Good afternoon, everyone. Thanks for coming to our talk. So we've talked a lot about layers, the proposed model, and potential applications. But now I'm going to ask you 2 questions. Is my team ready to implement AI tools? And do I make them or do I buy them? So let's start with the framework that everyone in this room understands. This is a very classic make versus buy decision that most of us probably learned in school or through years of organizational experience. But I'm going to offer a different approach, which is a true mix of these 2 decisions. On the make side, the logic is really straightforward. You build internally when you need control, whether that be over your IP, your data, or your system integration. And you also are going to make the solution when you need it tailored to a specific mission problem or organizational requirement. Or maybe you need deep alignment with your internal workflows and legacy systems. On the buy side, the trade-offs are just as familiar. Maybe you have a need for speed. Maybe you're buying to reduce your upfront investment and development risk. Maybe you're buying to gain access to mature and best-in-class technology without carrying the burden of development and maintenance. So this traditional classic model works well when the product or the software category is relatively stable. Capabilities are clearly defined, and the boundary between what we build and what we buy is very obvious. For decades, this has served us well, but the key point and the reason that we're showing this slide is because the traditional make versus buy model does not map cleanly to AI. AI tools don't behave like traditional software. They're modular, they're adaptive, and they're layered, and they're increasingly accessible to us as users. So this is really just a starting point. I want to talk more about the mix and how it applies to AI. So let's deliberately break the model that we just established. Unlike traditional software, AI really doesn't lend itself to a clean make versus buy decision. Instead, what we see in practice, especially in our industry, is a layered mixed strategy. Organizations are both making and buying AI tools, often at the exact same time. So let's start at the foundation layer that you'll see at the bottom of the screen, the buying the solution. So things you'll typically consider when you're buying an AI solution is continuous improvement of scalable tools, strategic advantages of building your own, level of training and data connected to these models. These are typically the commodity AI capabilities, kind of like that layer 1 that Daron brought up in our blue onion, the foundation or AI for all. There's very little strategic advantage in rebuilding these layers internally, typically. Hyperscalers and AI providers are investing at a scale and a pace in which most organizations cannot. So this is just AI for AI, infrastructure that everything else kind of depends on. So that's why you see it at the bottom. It acts as a foundation. Where AI becomes truly differentiating is above that foundation, in the layer labeled making the solution. This is where organizations should expect to do a little bit more making than they initially assume. Here, you're tailoring models and AI agents to specific mission workflows. Maybe you're getting into that layer 2. You're using proprietary or domain-specific data for tuning and context. And you're integrating AI tools into a regulated, classified, and security-constrained environment, which is something we know very well in our industry. Here is where AI is becoming digitally transformative, and it's a deep tech enabler, not just a generic productivity tool. You're moving beyond layer 1 and into the core of the onion. This is a critical concept to understanding the mix. You're not truly choosing between make or buy. You're deciding where and when each makes sense in your system specifically. As AI technologies evolve rapidly, the balance between make and buy is going to continue to shift over time. That's why we're talking about the mix. Low-code and no-code tools are lowering the barrier to internal development. Teams closer to the mission are able to safely prototype and deploy AI within guardrails. So when you are considering a layered approach, you're allowing your organization to move fast without sacrificing control. This is the critical part. You're able to innovate without rebuilding commoditized capabilities, and you're aligning your AI investments with mission outcomes rather than just the tools themselves. The advantage doesn't really come from owning the model, but it comes from owning how AI fits into your mission layers, your decision authority, and your operational reality. So let's take a look at what that mix could look like practically. Here's an example that is very common, something that's pretty simple to understand. You'll see the proposals team. They've made a tool. Maybe they have an internally developed LLM as a past performance database. Maybe they're getting into layer 2, where they're using an agent that's looking through all the past performance data and providing info specifically for the proposal that they're needing that past performance for. Below that, you see the marketing team. They're using the buy approach. They're in layer 1, commodity, AI for all. They're using the ChatGPT business account, and they're using it for content creations like captions and different taglines for campaigns. You see your HR team. Maybe this is a mix of make and buy, layer 1 and layer 2. They've purchased Workday, and Workday has an AI tool that scans and screens resumes and maybe matching them to specific positions they have. But maybe they've taken it a step further where an agent is recommending what resume needs to be fit to what job. You have your finance team. They've made a tool. They're in layer 2. They're using an internal model for cash flow forecasting. It's trained on their data because they had a specific workflow that they needed to work with. But they're using layer 2 because they're using an agent to recommend some things for them or give them specific actions related to their forecasting. So this is a mix, but the real transformation happens when all of these are integrated together. That's where you reach layer 3. So once you accept that AI is layered, the next question becomes, is your organization actually ready to support those layers, and are you getting value out of your implementation? So you're probably asking yourself this or wondering where you sit in the onion layers, or you're thinking about, well, what do I do with this? Maybe you're going down the arrow on the sliding scale. So we're going to bring it to a very practical standpoint. Assessing readiness and why. So this slide is about finding where the value really is, not where the technology hype suggests that it is, which is very common in a rapidly advancing technology like this. So who here knows what a TRL or a technology readiness level is? Okay, this one happens to be NASA, which is pretty fitting considering we're in Huntsville, Rocket City, and we're at the Space and Rocket Center. So I showed this to help us understand why TRLs, why do we use them? TRLs help us communicate where a technology is at in its life cycle, what risk is acceptable at each stage, and what it means to move from concept to mission-proven capability. When developing or proposing a new technology, you must have a way to communicate where the value lies. What we're proposing is to apply the same thought process, not to the AI technology itself, but to the organization that's implementing it. So now that we have the baseline of the TRL, let's look at the bullets on the left and understand why we chose to discuss implementation readiness and score organizations based on that. First, organizational culture matters, not in an abstract sense, but in understanding how your teams actually work, how they're sharing their data, and how they're trusting new tools. Second, every AI tool and every team is different. An AI tool that is perfectly fit for corporate communications may be completely inappropriate for engineering or operations at the exact same moment in time. Third, we need to be able to communicate readiness precisely. You often hear, we're experimenting with AI. We have an AI strategy. But communicating where an organization or a customer actually sits on a readiness scale is key to implementation. Just like TRLs allow us to say, this system is a TRL 4, not a TRL 7, we need a common language to say how ready we are to implement AI responsibly and at scale. This framing allows leaders to set realistic expectations, match the right tool to the right maturity level, but also avoid over-investing in tools that an organization simply cannot support. So this TRL is just for a frame of reference, but now we want to propose a practical framework that you all can use to assess where your team or your organization is at relative to AI usage and implementation, a balanced scorecard. At this point, you're probably wondering, how do we move from opinions about AI and something we can actually act on? So what is a balanced scorecard? A balanced scorecard, if you don't already know, is a structured way to convert subjective views, in this case about AI readiness, into objective shared understanding across strategy, operations, people, and risk. The balanced scorecard that you see on your right is a condensed version of a much longer balanced scorecard that was done for an organization in a complex, regulated environment. There's 4 key parts here. First, you see the perspective and factor. They're fairly similar, but the factor kind of narrows down the perspective a little bit. But all of the perspectives and the factors are weighted the same. The findings section gives a brief highlight of some of the key findings that are dictated in the score. In the far column, the score is for that factor particularly. The scores for this scorecard were 1 through 5. That was the scale that was chosen. The highest possible score was a 25 out of 25. 1 means you have very low confidence in your implementation readiness, and 5 means you're extremely confident in your implementation readiness. These findings were a result of interviews with company leadership, specific case studies with COTS AI tools, and also functional discussions and discovery discussions about internally developed AI tools as well. Most organizations are talking about AI readiness in a general term. Like I mentioned earlier, we're early, we're experimenting, we're ahead. But those statements aren't really actionable. Similar to a TRL presented previously, this balanced scorecard provides a way to communicate value. The balanced scorecard takes qualitative insights and turns it into quantitative action, replacing intuition with evidence, and it's aligning your technical, operational, and leadership perspectives. This is supporting defensible investment choices. In aerospace and defense, we don't really invest without understanding readiness, and we don't believe that AI should be any different. So let's talk about why we defined readiness. Let's take a look at the left. Strategic alignment. Is AI clearly tied to your mission objectives and the digital transformation strategy of your organization? Process and data. We believe this is foundational to all implementation readiness. Are your foundational workflows and data mature enough to support AI? People and culture. Do teams have the skills, mindset, and trust required to adopt AI? Governance and risk. Are security, compliance, and oversight addressed early and not after deployment? It's key to understand that none of these layers alone determine readiness. When all of them are considered together, you end up with a comprehensive picture of your team or your organization's implementation readiness and where that weakness might be hiding. Before we talk about the score baseline that you see, I want to highlight that the balanced scorecard showcasing a 1 through 5 for each category is not to assign blame or showcase where someone might be failing a little bit, but it's rather to create a common language across all of your factors, so that way your technical and your non-technical stakeholders can be aligned. So let's discuss the 3+ threshold. From my research, I found that an overall score above 3 suggests that your team or your organization can often implement and scale AI tools if the weaker layers are reinforced. Say that you rated a 5 on strategic alignment, but maybe your internal processes are at about a 1.5 or a 2. You can't expect to scale at a speed or an actual pace that is maintainable without addressing your processes and your data, especially because that's such a foundational layer. When we talk about implementation, especially through the lens of this scorecard, there's some key things that I want to highlight that you'll see at the bottom of the screen. You can start just about anywhere. Just because you ranked really low in one area or whatever, or you're on layer 1 or you're all the way in layer 3, there's always ways and areas to improve. You have to reinforce your foundation often. As the technology moves rapidly, your processes and data need to be advancing with them. You must enable your organization and you must govern for scale. This balanced scorecard approach lets leaders invest with confidence, matching your AI ambition to organizational reality. We've talked about a lot, but we have 2 closing charts to round this out so that you know exactly what to walk away with. So up to this point, we've talked about strategy, architecture, readiness, a balanced scorecard, framework, but now the question becomes, where do you actually start? This slide acknowledges a very important reality. Not every organization is in the same place, and that is perfectly okay. Let's think back to the multi-core onion model that Daron presented. Layer 1, individual productivity and literacy. Layer 2, standalone agentic AI. And layer 3, integrated agentic AI. With those in mind, let's look at the boxes at the bottom. On the left, maybe you're the company that says, we have no intentional AI use. For those teams, the goal is not to jump straight to advanced agents. You start in layer 1. You're getting everyone caught up to speed. Individual productivity and AI literacy. You intentionally identify a small number of layer 2 focus areas, but you're not going to rush them. And you deliberately delay layer 3. Enterprise integration without function creates risk, not value. Maybe you're somewhere in the middle. We use basic AI tools every day. This is where many teams are actually at. Layer 1 is already delivering value, but the next step is to tackle layer 2 with purpose. Custom, standalone AI agents that solve specific workflow problems. At the same time, leaders should begin planning for layer 3, identifying where integration might occur across teams to create synergy, but you don't want to deploy it prematurely. Maybe you're on the far right. We use AI every day, including custom AI tools. For these teams, this is where the challenge shifts from adoption to integration. Value now comes from connecting the AI tools across the functions. Shared data, shared context, and shared decision-making enable enterprise-level benefits. At this stage, AI stops being a tool and starts becoming a capability. Okay, so now in addition to a layered approach, you have a readiness framework and a scorecard that you can now use to continue your AI implementation, or maybe you're just starting it. Dr. Marx is going to provide a few closing remarks before we conclude.
Okay, we've covered some basics about AI, layered agentic AI, and an implementation framework. We're not standing here today as employees of Intuitive as if we've completed everything and we're done with our own digital transformation. We're working through all of these areas ourselves. We have some layer 1, we have some layer 2, we have some layer 3. We're working on all of it. But what we wanted to do is share our approach of how we're doing this across an enterprise. Hopefully there's something, either a nugget or the whole approach or some part of it, that you can use, that maybe it's helpful for you or your organization or your customer portfolio. I said earlier that the AI landscape and the agentic landscapes are changing. They are, and fast. Given that, it would be a little bit silly to expect to be done with this anytime soon. We may be in this digital transformation period for quite some time. But on my chart, I've got 4 takeaways for you to consider when trying to get value from your AI vision, the title of our chart. Number 1, understand that layered approach that we outlined today. Number 2, assess your maturity and readiness. Also on number 2, assess your willingness. People have to be able to want to go along with this stuff for it to go somewhere. It's not hard to find individuals in a group that love to use some of these LLMs and email things around and show how intelligent they are. Try to change that with a team of 50 people or 5 people or 500 people. It's much more difficult to get the inertia of a lot of people to do it than it is just for a handful. Number 3, assess your customers' maturity and readiness and willingness, all the same matter. If you're way ahead of them, you can be selling them something or advocating something they have no intention of using, or vice versa. If you're advocating something for which the customer already knows a tremendous amount, you're not at the right level and the right layer. And finally, add and smartly implement your strategy using some of those thoughts that we have today. So with that, Madison, Daron, and I thank you guys for your interest in our session. Thanks for joining us.
We do have 2 microphones in the room. If you have questions for our panelists, if you'll raise your hand, we'll bring the microphone to you.
Yep, we've got about 15 minutes for questions if needed. So raise your hand, and I'm Kyle or Anya, one of us will come to you guys.
Yep, in the back, thank you.
Hey, great presentation. Thank you. From our company, as well as Intuitive, we know how hard it is to adopt AI. Everyone in this room probably is in some of these different layers. When it comes to, you said on point number 2, the willingness of a team. It's very easy with 5 people. It's pretty easy with 10 people, 20 people. When you get to 500 plus, the adoption rate gets very, very challenging. What have you done, or what would you recommend in terms of encouraging adoption of using Gen AI or agentic AI inside your company?
That's a great question. Like I said, we're in the middle of that right now. We have pockets of people using AI for various stuff. In some cases, it's our younger staff members that really like it or recently out of school. Or in some cases, it's our more techie people that have a background in computer science. But across the organization, trying to get people to adopt it is hard. They might use ChatGPT for some scheduling and planning, but then they don't think about how they could use it. So what we're attacking through part of our own digital transformation is an organized, like a pyramid-type training approach, sort of a back to the basics, to make sure that people are aware with the basic, we're a Microsoft house, but the basic elements of Microsoft in a digital transformation, Teams, SharePoint, OneDrive, and then moving beyond that to OneNote, Power BI, with the step that further, if you go all the way to things like OneLake and Fabric. So we're trying that approach to get people exposed and trained to it. A lot of the things that we notice people they're not really unwilling to try, they just don't even know where to start. So we're having to kind of train and educate and help them. We're creating certain test cases to show them. Some it's Microsoft-led training, some is our own training, but it's all that kind of stuff to try to get people to go for it. Thank you. It's a good question.
All right, we got a question over here.
Good afternoon. Thank you for your presentation. I really enjoyed the structure that you put around this AI nebulous concept. My question is, since you brought up medical diagnoses and how AI is helping the healthcare industry, how would you deal with the issue of AI presenting, in your analogy of healthcare, an answer or a diagnosis, and that influencing the validation, you mentioned human in the loop, of the humans that are supposed to be verifying that that answer is correct? And this is an issue that's coming up in our company where people aren't, they're sort of reviewing the answer, but they don't validate it thoroughly. Like they kind of just take AI as gospel.
You want that one? Sure.
That's a great question. A couple analogs to that issue. In my background in advanced military aircraft, as many in the room are familiar in Huntsville, many military systems, we have any shooter, any sensor. We have a whole connection network of data sources that are then presented to a human to prosecute an attack. And one of the key questions is, what is the heritage of the information presented to me? In the old days, my radar display would show me a brick, and I know that that came from the radar. And my radar warning receiver would show me a triangle, and I know that that came from that system because they're all individual. But now with sensor fusion, I'm playing a video game, I'm presented a computer-generated chip, and it says it's an enemy, and it says there's no presence of friendly. Am I about to hit the pickle button and shoot a missile and take a life? This is a very challenging question, right? It's really a trust question. But I would say that it's no different in the abstract, it's no different than it's always been. If you have a hierarchy of humans in an organization and information is aggregated and moved uphill to a decision maker, this conundrum has always existed, right? How do I trust the people under me? If I'm the general officer or the final chief engineer that's reviewing the drawings or whatever, to what extent do I dive into the details? If I dive fully in, I'm gonna basically do everybody's job again that's already reviewed everything. So one of my answers is that the same practices, the same principles that are applied before computers still apply now, right? You have agents. You had agents before. They were human agents in hierarchy, in teams, and now you have computer agents in hierarchy, in teams with humans. So you're going to still need a well-designed review process. You're going to need relationship, right? So you have relationship with humans. I know Bob designed this. I trust Bob. Therefore, I'm not going to review it with as great a scrutiny as someone else's who's new to the team. You can pretty much translate that same language into computers, right? I've used this algorithm before. It's been proven. I've used it in this space, and I'm not now tackling an edge case. I'm in my safe spot. I can trust it. I'm going to apply an appropriate level of review. If it's a new tool or it's being applied in an edge case or edge of the envelope case, then I'm going to apply greater scrutiny. So I guess my primary answer would be is that it hasn't really changed in principle.
I don't have a perfect answer, but I do have someone that is in our network who I would love to connect you with, who's kind of doing a lot of research on this exactly about the cognitive bias that comes with not necessarily the trust in AI itself, but now the human has a little bit of bias towards some sort of answer because of what it's getting. So if you'll connect with me after, I would love to connect you with that person if you're open to it.
And you get all three of us answering your question. Part of that is the getting people to what I mentioned earlier, the training, kind of a LLM literacy 101 class is trying to get people to use LLMs. Part of LLM literacy 102 is don't trust everything you get out of the LLMs. So we've got to show people that, but then get them to understand that just because Copilot gives you an answer, you can't trust it. That's my simple answer. The more complicated answer, some of our team that really enjoy this kind of stuff, we've done research in trust in AI for a number of years. We've done it on autonomous systems, behavior cloning, advanced trajectory model, all sorts of things. Last year, one of our research projects was applying the field of trust in AI to large language models. We did some research using a blockchain consensus method to evaluate a standard set of questions with known answers among several different commercially available LLMs. And it's very fascinating to see what they give you. It all sounds very nice. They're all very professional and little emojis and MDOT stuff. It's great. But if you have known questions and answers in a systematic method, you can objectively show which ones are hallucinating, even though it sounds good. But that is a real issue. Thank you for the question.
I'll squeeze in one other quick tangential comment. Some of you may be familiar with the Geithner hype curve. It's highly relevant to any new technologies. So imagine an XY plot with a rapid growth and then a rapid decline to a trough, and then a little bit of a climb to a plateau. So that's the basic curve. And this happens a lot with new technologies. So there's a lot of hype, a lot of interest. It's going to solve everything. Remember 5G was touted as like going to bring world peace. I mean, has your life really changed that much with 5G? I'm not a 5G hater, but it seemed a little bit hyperbolic. So there's all this hype, and it's going to solve everything. And then that usually is followed by a rapid decline or a decline to a trough where everybody's like, oh, it's not that great. It actually... It's got all these faults, it's terrible. And then usually it rebounds back to the long-term plateau where it's in the happy medium. The iPad is this way. A lot of people, got tablets and then said, you know what, I really don't like to type on a tablet. I'm going to go back to a traditional laptop. And so it kind of achieves a happy medium in its right place over time. You alluded to that, so I want to bring that up.
Okay. Any other questions?
Anya, can you get that one?
Thank you all for your presentation. In our team, as we're working to create these standalone agentic tools for various isolated use cases, one of the things you talked about is eventually the goal being to create a more integrated system of these tools. So two things. First, I'd love to hear how at Intuitive you guys are doing that, as well as knowing that that's the goal, that we're looking towards doing that as we're creating our standalone tools and eventually going to try to approach a more integrated system. What should we be doing now, even though perhaps we're not there yet, in order to be creating our tools in a way that make it so we can reach that position?
Good question. I'll take that one, unless you guys want it. Okay. All right. A good example, at least an example that I'll use there of what we're attacking with Intuitive is in the talent acquisition field, talent management and talent acquisition. It's easy enough to make a simple agent in Copilot, for example, where we can upload 3 or 4 resumes, upload a job rec, and then query it and say, which one of these 4 people is the best match and give me some answers. That's nice. It gets a bit more complicated if I say, I've got a database of 1,000 resumes from current employees or additional people that have applied. I can't just click 1,000 times and upload those all into it and start querying. You hit context window limitations and all those kind of things. So in some cases, we're trying to use simple agents to show people the value of querying and intelligent prompting, maybe using RAG or something like that to get the information you want. But in other cases, that's where our development team is maybe making larger knowledge bases of all prior resumes or all new applicants so that we can have kind of an intelligent approach where maybe our agent might have an API interface to our HR system or our talent acquisition system. So we have that integrated agentic approach where we're not just querying and asking about a resume or just querying and asking to help me write a job rec and save a few minutes. Those are great applications, but we're trying to make it more of a foundational thing that changes the department behavior. I hope that answers the question.
Additionally, part of the answer is what Dr. Marx presented, and that's to apply system engineering to your organization. So as I alluded to or recommended, perform a functional decomposition, right? Love the verbs, live with verbs, decompose your organization's function to an appropriate level of detail, and then start seeing where things are slow or which decisions in that decomposition would lend themselves to machine decision making. And then again, look for, if you can find some that are adjacent, then you implement the layer 2 standalone agents, get them mature, and then they're already next to each other in your flow, right? And so then you would integrate them. And as Dr. Mark said, you identify interfaces and you have to define the information exchange and how they're going to work together. And then you might even create an overarching agent, right, that fuses it together to a greater degree, or that could be a human.